Hey everyone, welcome to the ratio test. So today's objective is to use the ratio test to determine whether a series converges or diverges. Okay, so if you've watched some of my previous videos, there's a lot of different tests we can use to determine whether a series converges or diverges. This is just another one of those. We use this specifically for what we call a power series. A Taylor series is a special kind of power series. So the general power series summation is from 0 to infinity of a sub n times x minus c to the n. A sub n equals the constant. C is some point, and we'll talk about that as we do several examples. So the definition of what the ratio test is the following. L, and you can use different variables. I'm just going to use L here. Depends on the text, so don't be surprised if you see some other variable. The limit, L equals the limit as n approaches infinity of the absolute value of your function plus 1 over the original function. So the idea here is you're going to get an a sub n, something to start with. And then you're going to plug in n plus 1 for n, and then you're going to divide it by the original function. Now there's three things that can happen with this ratio test. Number one, if L is less than 1, you have your sum is going to absolutely converge. If L is greater than 1, your series diverges. And if L equals 1, the test is inconclusive. It could either converge or diverge. So these are the three cases that we're looking at. So we're going to be finding some limit. Okay, so let's look at some examples. All right, number one, show that, example one, the sum from n equals 1 to infinity of 2 to the n over n factorial converges. So this series is going to converge. We need to show that. So I'm going to apply the definition. Okay, so what I can do is I'll take the limit as n approaches infinity. Here's my function. Here's that n plus 1 I'm talking about, the substitution, 2 to the n plus 1 over n plus 1 factorial divided by the original. Okay, so I'm going to simplify that, and notice in red, that's where the math is happening. What's in blue doesn't change. So I flip. I flip and multiply, so I have n factorial over 2 to the n. And now I'm talking about limits. So the limit as n approaches infinity, what I did is I matched up. I put 2 to the n plus 1 over 2 to the n, and I matched up my factorials together. Mathematically, we know that this happens 2 to the n plus 1 divided by 2 to the n equals 2 to the n times 2 all over 2 to the n. So this is going to simplify into 2. This, we'll show you what simplifies when we get to the other side. The n factorial over n plus 1 factorial is going to simplify just to being n plus 1. Okay, so, and you can mess around with that if you think about it, but factorials, well, I don't have the space for it, but you'll have to mess around with it to see why that simplifies, or I can show you in class, but you're definitely going to have to look at that. But this is what our equation or expression simplifies to, 2 over n plus 1. If I plug in a really large number for n, I'm going to get a large number, 2 over a very large number, which essentially means 0. So if my L value it's less than 0, this series converges, so I've gone ahead and shown that. Okay? Let's look at another example. Example 2. Does the series, the sum from 1 to infinity of n squared over 2 to the n, does that series converge? So this is a power series. Okay? So I use that definition, the limit as n approaches infinity of the absolute value. Here's my a sub n, but it's a sub n plus 1, so wherever there's an n, I substituted n plus 1, okay? Oops, not for that one. For this one here, so n squared is n plus 1 squared, 2 to the n is 2 to the n plus 1, and I divide it by the original, but dividing by the original is the same as multiplying by the reciprocal, so I've done that. So now I have the limit as n approaches infinity, and I matched up my bases and my n values together here. You don't need to do that, but I like to for simplification. Now what I did is I went ahead and multiplied the n plus 1. I squared that out. Okay, so I had n squared plus 2 to the n plus 1. remember 2 to the n divided by 2 to the n plus 1 is just going to simplify, so there's that 2, and then the n squared just stays. Okay, so the powers are equal here, so we take the limit, but when the powers are equal, now depending on if you watch other videos, if the powers are equal and we're taking limits and we're approaching infinity, there's a rule we can just divide leading coefficients. This is 1 over 2. There's my limit. It's 1/2. 1/2 is less than 1. So the series is going to actually converge. Okay, so that's the ratio test with 2 examples on how to show whether a series converges or diverges. I showed 2 examples of converging. Diverging is the same thing except for your limit would be greater than 1. Okay, so if you have any questions or comments, you can post them below. We'll see you next time.